Okay, the last new thing that we're going to talk about is a lot like just simplifying. Okay, it's a lot like simplifying. It's just that in the end, you keep simplifying and simplifying it until the statement that they give you is right. It's otherwise known as proving. Okay, proving a trig inequality, or excuse me, identity is a lot. It's a lot like just simplifying, and if you just kind of think of them that way, it's way easier. All right, so let's make sure that you get the stuff you're supposed to know up to this point, and that is the simplifying and solving part. Let's see if you can remember an example of each of the 5 major kinds of identities. All right, so for instance, there's the Pythagorean kind. I'd like you right now to write down one of the Pythagorean identities, the big one, the main one, the one that you can get everything else from. Remember, Pythagorean is implying a triangle, so maybe you can if you needed to, you could reconstruct that little triangle. Don't take out your notes. That's obviously not the point here. You're not going to be able to grab your notes on the test. We have to know these things off the top of your head. All right, here's the triangle I was talking about. In case you forgot, it was like this, and this was cosine, and this was sine. And it's sine squared plus cosine squared equals 1. And if you reverse that order, cosine plus sine equals 1, too. That's fine. Okay, that's the big one. That's the Pythagorean one. Now I'd like you to write down one of the other ones that you can get from that. In other words, there's another statement just like that. It involves like tangent. Remember what to do to get the one to turn into the other? What do? Divide everything by either sine or cosine, either way. All right. And if I want one that has tangent in it, I can just be intentional about what to divide by. I'm going to divide by cosine. That way, this will make tangent right there. So if I divide everything by cosine, the new one would be tangent plus 1 equals 1 over cosine, which is secant. All right, so there's your Pythagorean kind. And you could also divide everything by sine if you wanted to. All right, so I'd like you to write down one of the reciprocal kind. Anyone, just pick one. I don't want to say it, though. I want you to try to remember what the reciprocal ones look like. Don't just sit there. Make the pencil move. All right, Mr. D, what did you write down? Sorry. That is 1. And I really didn't care which one you put, just as long as you put any one. Because that'll remind you of all the other ones, right? Which would be like cosine goes with 1 over secant, or tangent goes with 1 over cotangent. Sine goes with 1 over... Oh, I cut that one, sorry. Yes, there are 6 of them to be exact. Don't have to write them all down, but that's another kind. All right, the third kind is like this. I don't know how to say it to you, so I'll just write it. Do you remember this kind? Where it's equal to tangent of theta, or then there could be a negative over there or not. They start out without any negatives. But then if you put a negative in here, you got to know whether there's a negative on the end or not. Which 2 of them does the negative actually carry over? Sine and tangent. So there should be a negative here for the tangent one. If you wrote the same exact thing with sine, there'd be a negative at the end. Which one does it not carry over on? Cosine. So if you see this, it should be plain cosine. There are 6 of those if you wanted to make them. You could have sine, cosine, tangent on the left here. Sine, cosine, tangent, and then also all the evil twins. And all the evil twins act just like their original. Like tangent goes with cotangent. They do the same exact thing. I could replace tangent right here with cotangent. And I would do the exact same thing. The mic is making weird noises. All right. Figure out some way to fix that. Next kind. This one, a lot of people, if you see this, you'll be reminded. It's just like sine of what? theta. That's right. And this is the one that's called cofunctions. Okay, there's one of the cofunction kind. Now, if I had just written this, a lot of people wouldn't have known what to write. But that's also the beginning of one. If I use sine, then I'd have to use cosine. And then I would use pi over 2 minus theta. So it does go both ways. You don't have to start with this kind. You can start with just plain old theta. All right, and then there's 6 of those. And then there is one other kind. Can you think of another kind? There is one more kind. Can't think of it? The odd even is that kind with the negatives in them. There's one more kind. It's very limited. There's only 2 kinds. Remember it? Yeah, it's the one with tangent. Tangent is equal to what? Yes. Those are called the quotient ones. And they get used actually a fair amount. Because anytime you can change something to sines and cosines, you're getting close to the end of the problem. It's one of the little secrets that we tell you. If you can't do anything else, if you can't do a problem any other way, get it down to sines and cosines left. And if you can get things boiled down to sines and cosines, it's more likely you'll find the right way to cancel everything out. All right? So anyway, these are the quotient 2. All right, so if you really understood that, and you know them as well as you should be able to replace these. Now, I'm going to do an example one before we start. So if I had said, for instance, cosine squared theta, I know, here's how I'd think my way through it. I can replace that with, well, it's related to this one. Cosine squared theta plus sine squared theta is equal to 1. So if I want cosine, I'd have to solve for cosine and get cosine alone. So I'm going to go like this, minus sine squared theta on both sides. And I'd have cosine squared theta is equal to 1 minus sine squared theta. I do not have that memorized, honestly. I don't have it memorized that cosine squared is 1 minus sine squared. But I can reconstruct it fairly quick. Okay? So my answer, if I had asked you for cosine squared, would have been 1 minus sine squared. All right? Here are 5. If you're where you're supposed to be, you'll get at least 4 out of 5 on this. Give it a shot. Okay, here we go. Sine squared. That one came from this. I should put a theta in there. Equals 1. And then I solve it for sine, so it's 1 minus cosine squared. Raise your hand if you had that one right. Okay, good. The next one, tangent. There's 3 things you could do. 1 over cotangent. That's pretty easy. That's a reciprocal kind. Who's got another nomination? Sine over cosine. And last but not least, and a lot of people forget this option. Yes. Cotangent, the cofunction to it is cotangent. Cotangent of 2 pi, pi over 2 minus theta. That cofunction one. All right, next, sine of pi over 2 minus theta would go with cosine of theta. Raise your hand if you had that one right. Good. The next kind is one of those negative ones. You got to think for a second. Cosecant is a lot like what? Sine. And the sine one, does the negative stick or not? Yes, it does. Negative sine theta. Raise your hand if you had that one right. Ooh. Uh-oh. I'm totally wrong. You're right. It acts like sine when it comes to the negatives, but it's supposed to have a cosecant. How many had that one right? Okay, good. Sorry. The negative sticks is the main point. And the last one, tangent. That one you can go back to secant. Yep, and this one's secant squared theta minus 1. Or you could do it a different way. Did anybody think of this? Sine squared over cosine squared. It will work. Is there anything else? 1 over cotangent squared. Very good. All right. So tangents have lots of options. Yes. Question. You can make further substitutions if you want to, but then you're starting to get farther and farther away from the original. I know what you mean. You could replace cotangent with something else from the... Okay. All right. So we can keep on morphing this even farther. I agree. All right. How many of you would have gotten 5 out of 5 on this quiz? How about 4 out of 5 on this quiz? All right, good. Then you're generally remembering them well enough. Simplify. So when you simplify, there is no equals and there is no like other side of the equation. Okay, and all you have to do is substitute things from your identities list and try to make things cancel if you can. And you can, if you can get it down to just sine and cosine, that'd be great. Or just one function like tangent. Okay? So a typical simplify problem looks like that. Just try one. That's a super easy one. Don't say it. Write it down. Do a substitution. You might end up having a simpler thing at the end if you do it right. All right. I'd rather have tangent in my answer than cotangent, but you could have done this the other way. Cotangent is 1 over tangent, right? Now I got it down to just one thing, and that's a good thing if you can do that. All right, so now, would you agree that I could have a fraction and a fraction here? I could sort of put this over 1, and now I can make it flip, and I'll end up with tangent theta over 1 times tangent theta over 1, which makes tangent squared theta. Is that what you want? Yep, that's what I want. Raise your hand if you had that one right. Okay, good. All right, moving on. To solve things. To solve things, you're trying to substitute again. And this time, though, get it down to only one function, and you end up actually having to solve it. You know, like use your rules to solve it, like quadratics. And there's a lot of times pre-quadratics, which are like things that are going to turn into a quadratic. All right, so let's do some solving ones. When you have these, don't forget they usually have 2 answers. This is a super simple one. Go ahead and give that one a shot. Solve it. Remember, your calculator can give you the answer, and I'll just be your calculator. Once you typed in inverse sine of 1/2, it would tell you 30 degrees. But that does not tell you the whole answer. Ugh, this crackly noise drives me crazy. Does not tell you the whole answer. 30 degrees is part of the answer. To get the rest of the story, you got to do one of these deals. All right. MV in the back row. Tell me what to do. Which ones work? ASTC. Okay. So the S1 works. And where else is sign positive? Yeah. So if I said it was 30, then that's one of your answers. Is the answer 30 over there? We say 150 because we go 180 and then back off 30. 180 minus the 30 makes 150. So the answer is 30 and 150. All right, next thing. How come sometimes you get 4 answers to these questions? Because sometimes there's more to the problem. Like for instance, what if they do absolute value of sine is equal to 1/2? Well, then that breaks them into 2 problems. Sine theta is 1/2 and sine theta is negative 1/2. And then there's 2 answers over here. Sine's positive here and here. And there's 2 answers for over here. Sine's negative here and here. So you have 2 negative answers. Those are the harder ones. Let's say that this comes out to negative 30. What do I really say then? I say 330. That's right. And then how about if it comes out to negative 30 over here? We take 180 and do what? Add the 30. Okay. So sometimes there's 4 answers because it's an absolute value. Sometimes there's 4 answers because it comes down to one of these deals where it's a quadratic. And you've got it all solved down to this. X minus 1. And then it's, and let's say that the thing started out as sine squared blah, 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 and I had substituted in an x for a sine, then I could substitute it back in and say sine of x plus 2 and sine of x minus 1. And then what do these mean? This means equals 0, and it's got its own two answers. And this has equals 0, and it's got its own two answers, unless either one of them is impossible. When this one, you actually go farther with it, you find out that sine of x has to be negative 2. Is that even possible? No, you can never have it be negative 2. You could have it be negative 1 or positive 1 or anything in between, but sine oscillates back and forth between 1 and negative 1, so it never will be negative 2 down here. So this would be none, or what's the official word for that? Undefined. So this part is undefined, and then I'd only have these two answers. I know, the crinklings drive me crazy too. I do have to have the mic on to record, yes. Sorry. I'll be done with it soon. So to prove things, that's kind of the last frontier. A proof looks just like a simplify. You just keep simplifying each side until they're equal. Well, let me give you an example of a proof that wouldn't have any trig in it. Okay, 3/6 plus 1/4 is equal to 3/4. First of all, you might even be able to just look at it and say, well, it looks like it's true to me. The way you'd tell it was not an equation is they'd have a question mark above the equal sign. It's saying, is it really equal to that? And what you do to prove it is you would do a substitution here. Well, with 3/6, you'd probably want to substitute in. Okay, we could make it 1/2 or we could make it 2/4. I like the 2/4 idea because then I've got the same units as this one. All right, and next, 2/4 plus 1/4 would make 3/4, and then just 3/4 on this side equals 3/4. If you can ever get that to happen, you can remove the equal sign. You have proved it. Now, what can't you do on these that you can do on a normal equation? What you can't do is multiply through on everything. Like, for instance, let's say we had 20 equals 0 question mark. Would you agree that if I multiply both sides by 0, that I'll have 0 equals 0? So didn't I just prove that 20 equals 0? See what I mean? You can't do that in a proof. Okay, 20 is not equal to 0, obviously. So you can't, when you're proving stuff, you can't do this stuff to both sides deal. You're not allowed to do that. So when you're proving stuff, you got to stay on this side. You can mess with stuff on this side. Separately, you can mess with stuff on this side. You can just simplify both sides all you want. All the simplifying and rearranging that you want. But you can't go through and multiply by something on both sides or divide by something on both sides. Yes? Nope. Can't move stuff from one side to the other. That's another good question. Nope. You got to keep this stuff contained over here and this stuff contained over here. All right. So let's actually do a couple. You have a worksheet today, which is called 5.2, and it's got a few on it. So let's just do it right on the worksheet here. One of the keys to this is you've got to show your work. It is a proof after all, but we're not asking you to write written proof like in words what's happening. Just show your work especially well. I know, it's a little different than what you did in geometry. All right, the very first one says cosecant squared x. Not done yet. 1 minus cosine squared x equals with a question mark 1. Remember, it's not necessarily equal to 1. We're trying to figure out if it really is or not. And we're going to try to prove that it is. All right, so now, who's got an idea of a substitution we could make that would make this work? Yes? So you're going to replace cosecant with what? All right, I will start that way and see where it leads me. And then this other side, do you want to make a substitution right away for the other side too? What's the other side you're going to substitute? You're going to make it sine squared? Because sine squared is equal to that? Because of one of those little rules that you learned? Awesome. Doesn't it look like those two are going to just cancel out and equal 1? All right, so it equals 1 over 1, which equals 1. And then you bring down your equals with a question mark, and you can remove the question mark. You have proven that it's actually equal. All right, so there's number 1. Did a couple substitutions, and it equaled 1. Why is this different? Because in the end, the other equations, you would have had to say, so theta has to be 30 degrees, or theta has to be 30 and 150. You're not doing that on these. These are actually easier, in my opinion, than the other ones. All right, so let's do another one. Let's do number 2. JT, would you read me that number 2? Question mark equals. Okay. All right. Any ideas? Yes, ma'am. You are correct. That's a great start. Sine x over cosine x. And I'm going to just keep this as sine x. But I'm going to put it over 1. Just because it'll be a little easier to see that those two can get added. Plus cosine x equals secant x. Now, I know that you might be thinking, wait a minute, that doesn't really help because nothing cancels. But it will help because now these two can go together, and what do they make? Sine squared x over cosine x. I can take a sine x times a sine x, I get a sine squared x. Plus cosine x. Now, this is the part where you hopefully are going to think that I taught you about common denominators for a reason. I started this whole unit talking about common denominators because I knew this kind of day would come. So, go ahead. I think something cool will happen once you find a common denominator here. Would you agree we're going to multiply by cosine x on the top and the bottom? That'll make this common with that denominator. And then we'll have sine squared x plus cosine squared x all over cosine x is equal to secant x. We need another substitution. There's a really good one. You got it? What is it? So this right here, no, you could go to the other side. You could do what you're about to do, but I got a simpler way. Can you change this for me? That's 1. So that all turns into 1. So it's 1 over cosine x has got to equal secant x. And now we have to take one last step. We actually have to say secant x equals secant x. And up to now it was a question mark. But now you can drop off the question mark and say, it's true. I've proved it. Get the idea? All right. One last thing. I told you I was going to talk about pre-quadratics. Here is a quadratic. You need to be able to see these coming. Do you get how that's really like this? Do you get how those are really alike? Look, you're not looking. This is just like this. So then I can solve it like this and say x and plus 1 and plus 1. And from there I just have to substitute in the tangent again. Now, my point is, I think most of you would be able to handle this one and say, okay, now this has to equal 0, or that has to equal 0, and they're identical, so I don't need to do it both of them. So I'm just going to solve this and say that equals 0. I think you can handle that kind. Now what I'm wondering is, would you be able to recognize it if it looked like this? This I'm going to call a pre-quadratic. See how there's no square root in it? And yet it's a quadratic. How? Because you're going to have to fix the denominator, so what are you going to have to do? All right. So we're going to multiply tangent on here, and here, and here, and here, but 0 times tangent is not going to do anything. So it'll turn into a quadratic. So watch out for those. They turn into quadratics. This one, tangent over tangent, is a 1. And 5 tangent x turns into 5 tangent x. So there's a quadratic again. It's got something squared. It's got a regular one. It's got a constant. And it equals 0. All right. That's all I got for you today.